All right. Yeah. Hello. Welcome, everyone. My name is Timur. Welcome to the very first ever London Audio Programmer Meetup. This is super exciting. I can't believe it. It's like the first time we're doing this. So me and Josh over here. Where's Josh? All right. Yeah. So we are your hosts. This is the first edition, and we're doing this the first time, and we're already booked out. We have a full house. This is absolutely amazing. Thank you so much for coming. This is super exciting. I'd like also to thank our sponsors, Focusrite and Sonics. So please, round of applause for our sponsors. Yay! I think some people from Focusrite are actually here tonight, right? Yep. Hello. Welcome. I would also like to thank Strongroom, which is this venue, this amazing venue here, for having us here. And please support them by buying drinks at the bar. They're amazing, this is great. What else? So obviously, we want this place to be kind of inclusive and safe and diverse. So what we would like to do is we'd like to ask you, so this is like a place where no matter what your background is, no matter where you are in your journey, becoming or being an audio developer, this should be a good place for you to be. So please be nice to each other, be polite to each other, be respectful. We have a code of conduct, which is the, sorry for that. Which is the Berlin Code of Conduct, which you can find at berlincodeofconduct.org. So this is going to happen every second Tuesday of the month, starting tonight. And the next one is going to be the next second Tuesday of the month, which is going to be Tuesday the 14th of April. Here, at the same time, we're going to announce the speaker soon. Speaking of speakers, if you would like to speak at this meetup, please let us know. Please write an email to Josh at josh@theaudioprogrammer.com or to myself, mail at timur.audio. And yeah, we welcome experienced speakers, first-time speakers, anything in between. You can do like a really short one, you can do a longer one, you can talk about anything you want as long as it's related to audio programming. Please let us know. It's, I think it's a nice place to give a talk, and we want to have a good range of different talks. So it would be amazing if many of you would be presenters here. So yeah, let us know about that. Tonight, we have the following agenda. So I'm going to start talking a little bit about C++20. And then we're going to have our main speaker for tonight, Dave Rowland over here, talking about real-time trade-offs. And then to conclude the evening, Josh is going to talk to us about an introduction to Juice. All right, so let's get started. So obviously, okay, let's ask a question first. So who here is an audio programmer? All right, most people. Who writes in C++? All right, quite a few people. So obviously C++ is by far not the only programming language that can be used for audio and music stuff. So obviously this is not a C++ meetup. This is not going to be C++ meetup. We're going to have a wide range of topics with other programming languages. So if you're not a C++ programmer, I hope we're not going to scare you off. I'm not going to scare you off now. It just so happens that C++ is kind of my area, so I'm going to talk about that tonight. But it's not about C++. We're going to have other programming languages as well. Speaking of which, let's talk about a little bit about C++. So before we do that, let's talk about this place. Anyone knows where that is? This is Prague. All right. So what does Prague have to do with C++? Does anyone know that? All right. So if you might know that C++ is made by a bunch of people who are the C++ committee. And there's a new standard, basically new specification of the C++ language coming out every 3 years. And the committee, of which I'm a member, meets 3 times a year, which means every new release is 9 meetings. So these are the last 9 meetings of the kind of C++20 release cycle. And as you can see here, the last one the 9th and last meeting of the current release cycle happened in Prague. And that was just 3 weeks ago. And what happened in Prague is that we finished the new C++20 standard, which is now done. So C++20 is now technically finalized. So I think that's cool. It's not officially published yet because there's some ISO bureaucratic stuff that's going to take a few months, but like I think a month or two from now it's actually going to be like officially the new international standard for the C++ programming language. But like all the technical work is done, the ink is dry. There's a nice YouTube video here which you can, if you Google C++20 is here, that's going to be like the first result with a few things, what actually happens at a committee meeting if you're not working on the specifications. So it's a bit funny, you can check that out. One of the things that happened there at this meeting a few weeks ago is that we had a kind of party to celebrate the release. Of course, if you make a release, you always have a release party. So that release party was pretty epic. We were in like this big Gothic church, and it was really special. We made this picture in the end with all the people who were there, and quite a lot of people. So that was really cool. And I just want to talk a little bit about what's in this new release, what's in the new C++ 20 version. So there's, I think, about 100 features there. But I think these 6 are kind of the most important ones. So we have coroutines, we have concepts, we have ranges, we have modules. You can now use floating point types like float and double, and also user-defined kind of classes as non-type template parameters, which is really cool for audio if you want to write, for example, look up tables and template them on some kind of floating point parameter and things like that. That's really, really cool. And you can do a lot more stuff at compile time because there's a lot of things that are now const expr, like std vector and std string, which you now can use at compile time, which is pretty cool. So, and I think out of these like 100 features or so that we have there, these 6 are the most important ones because they don't just give you like new tools or new ways of writing things, but they'll actually change the way you think about code. Oops. That was not good. This does not look particularly safe. I'm gonna stand a little bit over here. Yeah, we're back, okay. Sorry for that. Right, so these 6 features, they're gonna change the way we think about functions, classes, the way we design libraries, the way we compile our code or like arrange our projects. So they really will. Hello? All right. Cool. So let me just talk a few minutes about some of these things. Let's talk about coroutines. I think this is probably one which is particularly interesting for audio if you're doing audio in C++. So coroutine really is kind of a special case of function. So what's a function? This is kind of our mental model of a function. It didn't really change since the 50s. So basically the idea is you call it, you might pass it some parameters, which is not actually important here. It's going to run some code and it's going to return some value, right? This is the concept of a function, which didn't really change the last 60 years. Now, if you want to call a function, let's say you want to call a function that returns something different every time. Let's say we want to have a function f and that we want it to return 0, 1, 2, 3, 4, 5. How would you do that, right? So in order to do something like that, if you don't want to like pre-allocate the whole thing in memory up front, you need to have some kind of internal state, right? So you can't really do it with a function. Maybe you can have a counter, which is like a static object, or you can write a class. You can write, and then a class has members, and then you're thinking about objects and classes, and everything becomes a lot very complicated. And I don't think for something like this is really the right way of think about this. With coroutines, we can actually do it much easier because a function already has a state, right? It has local variables inside. So with the coroutine, what you can do is basically, it kind of extends this mental model of a function. So you can have a function, you call it, it runs some code, it maybe initializes some local variables, and then that's the state of the function at this point in time. And then it can yield a temporary value and suspend. And next time you call it, it's going to just continue and yield the next value. But it's going to kind of remember all its local variables. So you don't have to create a class, anything like that. So what you can do with coroutines is you can, for example, say, all right, let's going to have a counter I, which is just a local variable, and just have an infinite loop. And every time around the loop, you're going to increment it and yield the value. And then every time you call it, it's going to yield the next value. So that's like really kind of simple, efficient, kind of low a kind of low overhead kind of way of doing this. It gets even more interesting because we don't just have yield, we also have weight. And what a weight actually does is, so if you say you have a function f and you say co-weight g, what actually happens is it returns, but also it resumes if g yields a value, right? So it's kind of this cooperative thing where a function returns, but if this other function g then yields a value, then it's going to jump back into f. So what actually happens here is that if you say co-weight g, you're kind of registering a callback for when g is going to be called, and then you return. And then if g is being called on a different thread, and then yields a value, then you're going to call back into this thing. You're going to resume f again. So, and that can happen on a different thread, right? So you kind of register a callback, return, then on a different thread, someone call g, and then g yields a value, and then basically the second half of the function on the left is going to turn into a callback for g. But the cool thing about this is that you don't have to write any of the stuff yourself. The compiler is just doing it for you, and it's doing it very, very efficiently. So, you know, in audio, if you write this in C++ or similar programming languages, you sometimes end up in this callback hell. You do a lot of stuff with callbacks. You don't have to worry about this anymore ever. If you do this with coroutines, I actually tried this, and this is true. Like, the code becomes half as long and a lot easier to reason about. So I think this is really going to change the way you write audio code if coroutines become accepted by the community. I'm really looking forward to audio code being written in coroutines, and maybe someone can give a talk here about this at some point. The other thing is concepts. So let's say this is something that actually happens in my day job quite a lot. Let's say we have a function that checks whether an integer is a power of 2, right? This is a very useful function for audio. So this basically is a clever implementation here. It turns true if you have exactly 1 bit set, but it only works for ints. Of course, you want to work it for any integer type. So in C++, you make it a template. Okay, great. Now you call it with something that is not an integer type, right? You want to call it with maybe a double, and then that doesn't work. But then the error message you get is it doesn't really tell you what that means. So if you try to call it with a double, it's going to instantiate the template. But then it's going to fail because some of the expression inside doesn't quite, so the compiler is going to hit an expression that doesn't compile for a floating point number. And you get this weird message where you have to look into the implementation to figure out what's going wrong. This is kind of the problem with templates. So, okay, great. You know, we can say static assert that it's an integral type. That's cool. It's going to give us a much better error message. But what if you want to implement this for a double or for a float, right? Whether a float is a power of 2, and we want 0.5 to be a power of 2 as well. There's actually a clever implementation for this, where you kind of can use the std_frexp to kind of decompose a floating point number into mantissa and exponent. Doesn't really matter. It works, but it's very different, right? So this function looks very different from the other one. And this one is for integers, the other one is for floats. And now if you want to call it with a float, what you get is another error, which is saying, well, you redefined the same template 2 times. You can't do that. So now you have to do sphere and enable if, and I'm not sure if anyone has done stuff like this, but you know, you have this horrible template meta function, and where do you stick it? Do you stick it on the return type, but then you don't see what the return type is? Do you stick it in the parameter list? No, you can't really, like, it doesn't quite work, so you put it in the template parameter list, but then that doesn't work, so you have to make it a non-type template parameter. So this is completely unusable. Like, I can never remember how to do this properly. You shouldn't be doing this. So in C++20, you can just use a concept, right? And that's much better. So you can put it here, and actually it tells the reader much clearer what's going on. And actually there's different ways of writing this. This is like the long form. Oops, sorry. You can write it a lot shorter by just putting it here inside the template parameter list. And you can also, at the top, you can just omit the whole template thing and just make it an argument. And now it's like really short and really nice. But it's not just a way of doing sphere more easily. It's like a whole kind of concept in itself which changes the way you design libraries. So these concepts like integral, they're composable. You can say, well, maybe I have an arithmetic type, and that's if a type either is integral or floating point. And then C++ is this annoying thing where it thinks that character types like char and unsigned char are also arithmetic types. So you're going to say, well, maybe I have a number type, and that's arithmetic, but not if it's a character. And then you have this new number concept. And then you can just write a function like this. And this is a template which is going to take any number. But you don't have to like write all this like template meta-programming boilerplate. It becomes really short and really nice. And then you actually can even say, well, I want to accept types that have a certain interface. So for example, if you want to write a hash map, you want to accept any type that for which you can compute a hash. So you can say, well, if this expression with the hash compiles and returns something which is convertible to size t, basically like an integer type, then this is a hashable type. And you don't have to introduce like a base class like what you would do in Java. You just say, well, if this class has this interface, then it should compile. And you express this in code. Like previously you would have to express this in the documentation maybe. And then the user would have to, like, when they hit these like really long unreadable error messages, you would hope that they read the documentation. Sometimes they don't. Now you can express this in code. So I think this is really nice. And then you can say, well, your hash map is going to be a template on any type that has this interface. So the last thing I want to quickly mention is modules, because modules are actually, I think, the most important, by far the most important feature of everything we have in C++20. And modules are the thing that's going to replace headers. And I'm sure everyone who has done C++ is familiar with the pain you have to go through if you program with headers, right? So first of all, you have this weird split between header and source files, but then if you're writing a template, it has to be header only, so it's kind of weird and inconsistent. Then, depending on the order in which you include headers, you might get different results, you might get weird errors, and then you kind of randomly start switching your includes around until it compiles. I'm sure everyone has been there. I certainly have been many times. And then, when you find the error, it turns out, well, this is because you defined a macro before you include, and it kind of leaks into the header, or you have to find the macro inside your header, and then it leaks out and affects the next header that you include. So it's like really messy, and you can have cyclic dependencies between headers, and then, again, it depends kind of on the order. Headers don't really let you encapsulate anything, because everything that's in a header is just going to get copy-pasted into your source file. You don't have any way of saying, yeah, but you're not supposed to use, you know, this class. This is like a private thing. There's no such thing for headers. So some people do like a detail namespace or something, but it doesn't really work. And then also, it's very slow to compile, because on the one hand, if you have headers and then you include them and you have translation units, it's nice because you can parallelize it, because every translation unit can be compiled on a different core or whatever, like, because they're independent. But on the other hand, if you include the same header 100 times, you have to parse and compile a header 100 times, and that's really, really, really slow. So modules basically fix all of this. So just very briefly, you know, if you remember our little power of 2 function, now you can stick it in a math module, and you can say export. And you know, if you don't put the export, then it's private, basically. And this is not a header, this is what we now call a module interface unit, which is like a new thing. It's not a header, not a source file, it's this new thing. And the difference here is that no macros can leak in, no macros can leak out. It can't cyclically depend on anything. And then what the compiler does with it is turns it into a BMI, or it's called a binary module interface. So it's actually going to transform the code into something that where you can really quickly, the compiler can really quickly look up all the names in there. So it's going to be really fast to compile. And then you can do something like this, where you can say import math, and this now looks a lot like Python, which is actually really cool. And now if you have multiple imports here, then the order doesn't matter, so you can't have cycles. All of this pain is going away. So you just say import math, and then you can use this function here. And this is really nice. So I don't want to talk too much about this. I have actually, just 2 weeks from now, I'm going to talk for 90 minutes about all of this stuff, if you want to know really how all this works. It's going to be at the ACCU conference in Bristol, which is a couple hours on the train from here, and I think it's going to be on YouTube afterwards. So where I'm going to like properly explain what this means, and I think these features are going to really change the way you write audio software in a good way. And actually, the support for this is kind of really, really good already. So there is this long list on CPP reference, like which compiler supports which features, and the first few columns are kind of the important compilers, and unless you do embedded. So there you might have to wait a bit more to get these features, but if you're doing desktop or mobile software, then most of it kind of already works. Like, for example, GCC doesn't do coroutines yet, I think, and so there's a few gaps, but I'm pretty sure that by the end of the year, basically all of the major compilers will support all of these features. So we're going to get to use all of the stuff really, really soon, even if you're doing cross-platform software. Right, so this is kind of everything I wanted to say about C++20 today. I think this is really going to change the way we write code. Right, so I'm done. This was kind of a little introduction talk. Now we're going to move on to the main talk of the evening by yeah? One question? Oh, yeah, do you have questions about this stuff? Sorry.
One quick question.
Yeah.
So Mike asks, how do coroutines in C++20 impact the stood audio proposal? Is the callback approach still the proper abstraction?
Well, that's a good question. Should I repeat the question? Maybe that was not. So the question was, because we're working on the stood audio proposal as well, how does the coroutine stuff, which we now have in the standard, affect that proposal? It's a good question. So obviously we could go ahead and rewrite the whole proposal in terms of coroutines, and actually someone did that, like Frank Birbacher went ahead and kind of made a version of the callback interface using coroutines, and it kind of looks nicer, but we're not sure yet, because if you had a model where you would yield like one sample at the time, it would be like really straightforward. But what you actually do is you do like buffers, so you would have to yield one buffer at the time, and you would kind of. So at the moment, we're not convinced that specifically for the audio proposal, the coroutines are going to lead to something which is a lot better. But this is basically future work. So this year, I think we're going to spend some time looking into this a bit deeper and decide whether we should go for coroutines. I think it's an open question. So thank you very much for the question. I'll keep you updated. I don't actually know the answer yet because we haven't decided yet. We haven't looked into this in enough detail yet. Right. Any other questions about C++20? No. Okay. Well then, thank you very much for your attention. And I'm going to pass over to my very good friend Dave Rowland over here, who is going to deliver his talk. So big applause for Dave.